Intensity distribution curve for interference. Here, these peaks corresponds to bright fringes and these points correspond to dark fringes. Here, this is dark fringe, this is bright fringe, this is dark fringe, this is bright fringe, this is dark, then bright, then dark, then bright, and width of each dark and bright fringe is the same. This is position of central bright. This is intensity along this line. And here, this is distance from central bright. So OD1 is equal to half of fringe width beta. OB1 equal to 1 beta. OB2 will be equal to 2 beta. Similarly, D1 to D2 will be equal to 1 beta. So intensity of a bright fringe is I max, and that will be given by I max equal to K times A1 plus A2 whole square. Here A1 equal to A2. So K times 2A whole square, that is 4A square, or 4Ka square, which is constant. So intensity of maxima means here maximum intensity at the position of bright fringes is 4Ka square, and intensity of a dark fringe at this position I minimum, assuming A1 equal to A2, will be K times A1 minus A2 whole square, that is K times A minus A whole square, that will be 0. So intensity at dark position is 0, whereas intensity at these points like B1, it is maximum. Now let's consider second point, conservation of energy in interference of light. There is no violation of law of conservation of energy in interference. There is only redistribution of energy. Energy disappears from dark fringe and appears equal energy in bright fringe. So I max is proportional to A1 plus A2 whole square, and I min is proportional to A1 minus A2 whole square. If we try to find the average, so I average is proportional to A1 plus A2 whole square plus A1 minus A2 whole square divided by 2. So this will become I average proportional to, if we open the bracket, then we will get twice of A1 square plus twice of A2 square whole divided by 2, and other terms will cancel out. So ultimately, I average is proportional to A1 square plus A2 square. And if in terms of intensity we write separately, so I will be equal to I1 plus I2, and that will be equal to the same thing. So it will be equal to A1 square. So here we have to use some proportionality constant, K times A1 square plus K times A2 square. Now, next thing, comparison of intensities of maxima and minima. So we know that intensity is directly proportional to amplitude square. So we can say I1 upon I2 will be equal to A1 square by A2 square. And we know that amplitude at a maximum, so wherever maximum occurs, then becomes amplitude for maximum. It's sum of A1 plus A2, and for minimum is A1 minus A2. So now we write intensities at maximum divided by intensity minimum will be equal to maximum amplitude means A1 plus A2 whole square divided by A1 minus A2 whole square. Now, if we take out A2 from here, so we will get A2 square, then here it will be A1 upon A2 plus 1 whole square divided by, from here also if we take A2 square, then it will become A1 upon A2 minus 1 whole square. So A2 square will cancel out, and let's write A1 upon A2 equal to small r, which is amplitude ratio, which is also equal to root I1 upon root I2. So we will get I max upon I min equals, this is r plus 1 whole square divided by r minus 1 whole square. And also we know that slit width is directly proportional to intensity. So we can say if W1, W2 are the width of the two slits S1 and S2, in that case W1 upon W2 will be equal to I1 upon I2, which is equal to A1 square divided by A2 square, and that will be equal to, as we have defined here, A1 upon A2 equal to R. So this will become R square. Thank you for watching.